About an X sub question, and if you get one in a test or the final exam in this case, you won't need to figure out that it's an X sub because it will be given to you as part of the question. So let me choose one and show you the process then. Let's suppose I'll take out a number one. Let's suppose we do this one. So you've been asked to find the integral, so it's an indefinite integral of x squared take away 49 all over x cubed dx. And in the question, you'll be told the x sub. So that at least makes it a little bit easier to do. And the x sub in this case is 7 secant theta. Right. So your job is now to figure out how to continue that process. So it is a version of substitution. So what I'm going to do now is I'm going to differentiate x with respect to theta. I'm going to ask, does anybody remember what the derivative of secant is?
Was it secant tan?
It is. And so this integral, little crossover. So what we now do is replace everybody. So the x is going to be replaced by 7 secant theta. So x squared is that guy. Take away 49. On the bottom, I'm going to have 7 secant theta, the whole thing, cubed. And instead of the dx, I'm going to have another 7 secant tan theta d theta. So the first part, it's really two major parts in my opinion. The first part is that you take the integral in x's and you replace it by a different integral involving theta. And this integral will always have trig functions in it, right? Sines, cosines, secants, tans, whatever, as it has here. We then have to go through a whole load of, just getting it pretty. So that's what I'm doing right now. So 7 cubed is 343 secant cubed. This guy inside the square root is 49 secant squared theta, take away 49. And I'm just rewriting all this stuff again. I guess I could do some cancelling while I'm at it, although I could wait till later, it won't matter. If I do that 7 and it cancels into that guy, that'll leave me 49. If I take this secant and cancel it with one of them, that'll leave me with a secant squared. So the bottom now is a little bit simpler. It still leaves me with a tan theta d theta. I could do that. Hopefully I can do this in one go. If you take 49 secant squared theta, take away 49, isn't that the same thing as 49 secant squared minus 1s? But what is 49 secant squared minus 1s the same as? Because it's an identity. Essentially, what's secant squared minus 1?
Tan squared.
Tan squared. So what you get is the square root of 49 tan squared. And if you do these x subs, that square root always ends up being 49 sine squared, 49 tan squared, 49 secant squared, right? It's always a single thing squared, right? It's always going to be that way. It's kind of the way it's structured to have. Now I can continue with the simplification process. That's going to be 7 tan times another tan, so I might as well square it, all over 49 secant squared theta. I'll move it over here. Not too much left. I guess I can cancel that. And now I'm left with tan squared theta over secant squared theta, d theta. In case we lose track of the bigger goal, we're eventually going to find the answer to this integral. What we've done is we've turned it into a different integral that involves theta. And we're at this point. Now, what you get here is very variable. It could be anything. I've seen questions where what you got here is cosine theta. And you go, oh, great, that's easy to do. And then sometimes you get sine cube theta, cosine theta, in which case it would be a u sub. Right now, I've got a tan and a secant squared. And we have to figure out what we can do, style points, to make this guy work. We could, right, do a u sub. Did we? What u sub would work for this question? Oh, I take it back. Forget that idea. If the secant squared, yeah. What I'm going to do, you're right, is to turn everybody into sines and cosines. That u sub, I'll tell you what I was thinking. I was thinking tan theta would get me secant squared, and then I suddenly realized the secant squared was the wrong place. That isn't at all, no good. Now, this fella is sine over cosine, so when you square it, you get this. Secant is 1 over cosine, so when you get it, you have this. So what I now have is sine squared over cos squared times cos squared theta, essentially over 1, right? Because dividing is like multiplying. And something nice happened. Our question now became this fella. So style points took this massively ugly thing and reduced it to this. And now I have to figure out how I'm going to integrate sine squared. I'm going to use a trig identity. There are two versions of sine squared. One of them is that, but that's not much use. Does anybody know what the other one is? There are two versions of sine squared. What's the second one? Okay, I'll give you a clue. It's a half of something. Still no biters? 1. Take away. You remember that guy? Cos squared is a half, brackets 1 plus cosine 2x. Sine squared is a half, 1 minus cosine 2 theta. So this fella is now going to be that guy. And this fella becomes that fella. And now I can integrate. A half gets me a half theta. And if you integrate a cosine, you get a sine. Because it's a sine, a cosine of 2 theta, you get an extra half. So that's where that gun came from. So we've taken the original and we've integrated it. The only problem is that it's in terms of theta, and we need to convert it into x's. So you go back to your x sum, and this is going to create a triangle. Divide it to get that, And then I know that a secant is 1 over a cosine. So what that tells me is that cosine is 7 over x. If the secant is x over 7, the cosine is 7 over x. We build a triangle. We'll make this angle theta. We call this side the opposite. This is the adjacent. This one here is the hypotenuse. I know that a cosine is an adjacent over a hypotenuse. So that allows me to figure out that this is 7 and this is x. How do I find the third missing side of this triangle? Or just tell me what it is, I guess is the short way of doing it. I know these two. How would I find this one?
X squared minus 49.
Do you notice this guy over here at the original question? Remember, that was a good sign that everything's going right. See them matching? Right, so what's this guy's job? This guy's job is to turn these things, right, into x's. Now, in most questions, the thing that you have will be sine squared, cosine thetas, and things like that. This one's a little bit different. You've got a theta on its own, and you've got a sine of 2 theta. So we have to deal with each one of them. I'm going to start with this fella here. Do you see how the cosine of theta is 7 over x? That makes theta the inverse cosine of that guy. You are, of course, allowed to use this fella, which makes it the inverse secant of x over 7. These two things are exactly equivalent and therefore are both fine. Either one of them will do. So that's what theta is. Now, to remind ourselves what the answer that we're trying to convert is, it's this fella. Well, I know theta, I'm using that version. So it's going to be a half of the inverse cosine and sine over x. Then we take this fella, and no, you don't find the sine and double it. The sine of 2 theta is a little bit trickier than that. You need to know another identity. Let's try for this one. The last one wasn't too successful. It may, hopefully this one will be. What is the sine of 2 theta written down in terms of sines and cosines? What's its identity?
2 sine theta cosine theta.
Yeah. So this guy is going to be times 2 sine theta cosine theta. Those two together get me a half. And to get the sine, I do opposite over hypotenuse. So the sine is opposite, just that guy, over hypotenuse. And the cosine is adjacent over hypotenuse. And we are finished. It's a half of these. That, and that, if you put all that together, you get -7, this square root, all over 2x squared. Now, that particular question is definitely a section 2 question. It is massively big. Of course, because it is such a big one, it's probably worth 30 points rather than the average 25 points. So you get more points for doing it as well. And partial credit comes into play because it may be that somewhere in that, what, it's a 3-pager, isn't it? Somewhere in that 3 pages, you may have, you know, lost a sign or done something. I think one of the things it tells me is that shouldn't you have a nice piece of paper with trig identities in it so that you just have one piece of paper and you bring it out and you have it in front of you so that you can Convert the sine square to this and convert the sine 2 theta into that. Without those trig identities, that question kind of stops, right? We can't go any further. It's a good question, Evan. Kind of depressing question, because when you see something as big and as ugly as that, it frightens you, or it should. But not every question in the final is going to be anywhere near as big or as ugly as that, right? There are going to be some much nicer ones as well. And half the things you study for the final won't even be in the final exam. If I gave you a question on every single thing, I'd need more than 10 section 2 questions, wouldn't I? So you're not going to see every single question. But I'll tell you Murphy's Law. See the half you don't study for? That's the half that's in the final. So you have to prepare for everything and hope that some of the ones you're not so good at don't turn up. Or the alternative of that is, don't you want the ones you're good at to turn up? Let's be positive. Yeah, I'm really good at volumes of revolution. I hope we get one of them. That kind of thing. Or I'm pretty good at linear differential equations. I hope we get one of them. You know, that kind of thing. Okay, where are we off to? What's the next topic?
Could we do surface area, please?
We can. I can see right away that we are not picking the easy ones, which is good, because you probably don't need practice at the easy ones, right? You know how to do those. It's the X subs that we've just done, and I'm looking for surface area as we speak. Here we go. Same problems before. I have to pick one of their questions. If I make one up, it won't work. Do you want a surface area question that ends up giving you a perfect square? Is that the kind of one you want to see?
Maybe one without, just because I have a lot of perfect square examples.
Right. So you want to see a not perfect square one. I got you.
At least for myself.
Yeah, why not? So we're being asked to find the surface area of this function between 2 and 8, y2. It's a funny number. I'll make it 4. I can change that. Doesn't change the question. Not in any substantial way, at least. Oh, what we got in chat? Okay. Because this particular one is about the x-axis. So the surface area is the integral from A to B. Anybody want to plug in the formula? Anybody off the top of their head remember it? Or find it? 2 pi. Even if you can only remember a bit. What comes after 2 pi?
F of x.
Followed by square root of 1 plus
F of x squared.
f dashed of x squared. Okay. So you do get a formula sheet that will be accessible in Canvas, right? That won't be blocked off. So you could just basically go and look that guy up. If you have it handy, you memorize it, it's so much easier. So I got a lot of preparation to do before we go anywhere near this. Essentially, that guy there is going to cause the trouble, right? The square root. Integration with square roots don't play well together. You typically are going to have trouble. There's going to be a lot of algebra. Many times, but not this time, you get a perfect square eventually, but not this time. So I'm going to start off with that guy, who's basically who f of x is. And I'm going to rewrite it as a fractional power. I'm going to find its derivative. So I'm going to multiply by the power and reduce the power by 1. Is there anything I have missed? Because this is differentiation stroke chain rule version.
Stick the derivative of the inside.
Which is -1, correct. So the derivative is -1/2 8 minus x to that guy. And 1 plus the derivative squared is what goes inside the square root. So it's 1 plus this ugly guy squared. Okay, if you've got various things multiplied together, but they're all being squared, you can square each one individually, which actually makes life a little bit simpler. -1/2 squared is -1/2 times another -1/2, and you end up with +1/4. This fella, if you square this, don't you basically multiply them together and you get that? You double the power. That's how you square things, right? You double the power. And I think I should put the one a little bit more central, right? This is him. Because I need to make this thing here, right? I'll just rewrite it again because it's kind of messy. I need to make this thing here as simple as possible. I have to do style points on it. And style points are really just my word for simplifying it as much as possible, right? Reducing it, putting it together, factoring it, make it look like original, all those kind of things. What do you think I'm going to do with these two things? What do you think I should do with these two things?
Combine them.
Yeah. So I'm going to turn 1 into 4 8 minus x's over 4 8 minus x's plus 1 over 4 lots of 8 minus x. And the top gets me 32, take away 4x, add 1. And I'm going to leave the bottom like that because I kind of like the way it's written. Not a lot happening on the top. It looks like I get 33, take away 4x. And there's nothing I can factor there, so that's it. This is what 1 plus the derivative squared looks like. So I'll now go back to here, and it's going to be the integral from a, which is 4, to b, which is 8. I'll stick the 2 pi outside. F of x, which is this fella, times 1 plus the derivative, which is this ugly fella. So 2 pi f of x, the ugly square root. And now we think style points again. Before I even try and integrate that, wouldn't it be a good idea to make it nicer, something easier to work with? Any suggestions about a different way of writing that?
The square root of the top over square root of the bottom, so
Right.
2 times the square root of 8 minus 6.
You all happy with what you just said there? That's exactly what you should do. Now, when you look at that, what you hope to get is something like this. Do you see that these cancel? And do you see that half? If I bring that half outside, won't it kill off that 2? And now I've got a pi. And so my surface area ends up being this much, much simpler integral. By the way, you're happy with the 2 in the bottom cancels the 2, right? How would I integrate this guy?
U sub.
I would do a U sub. And who would the U sub be?
-33 4x.
Yeah. In a way, I think that's a silly question, isn't it? Because what else could it be? There's nothing really going on. Right, so if you differentiate with respect to x, you get -4. If you do the crossover, you get -4 dx. And if you isolate it, you get -1/4 u dx. So we have pi, an integral, the square root of u times -1/4 du. And I'm going to suck that -1/4 out. And we're now looking at that. I mean, every step gets a little bit closer to the end. Are you comfortable about, oops, you comfortable about it now? Okay, how do you find this, the integral of the square root of u? This is about the 40th time we've had to integrate the square root of u. It's probably an exaggeration.
2/3 u to 3/2.
Oh, you're telling me the answer, yes. You turn it into a half power and you get 2/3 u to the 3/2. There's a -1/4 going on here. When you put these guys together, that partially cancels. So you now got this. And the 3/2 becomes that guy, which then becomes, I'd actually probably do it that way around. It's easier to compute. So rather than cubing and then taking the square root, I would probably take the square root and cube. Now, you then evaluate it at x equals 4 and at x equals 8. And dot, 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 dot. Isn't that just putting in some numbers and you'll get some ridiculous answer like -6 pi. I don't know. Well, actually, that's not bad. That's 1. And the other one is what? 15. So it would end up being -1/6 pi, 1 take away the square root of 15. So I guess it wasn't as ugly as I thought. Now, in a lot of questions involving surface area, this square root thing ends up being a perfect square, but there's an example of it not being. The same thing's true about arc length. Aren't a lot of arc length questions perfect squares in the square root? When you do an arc length question, your formula is the integral from a to b, square root 1 plus derivative squared dx, right? And so if I just took this bit out, wouldn't our question really just be to integrate that thing? That would be very difficult, actually, so that probably wouldn't be a question you'd be asked. But that's the process. Another massively long question, which when they get this big, they're probably 30 points on 25. But then again, there's a lot of shorter questions that are only going to be worth 20 because they're a lot shorter. But all section 2 questions are 20, 25 or 30. They average out at 25.
Could you show me how to complete a specific question from the homework?
Sure. Which one?
Question 10 from section 9.3.
Is it something you could tell me? It'll save me having to go in and out and find it. If it's short, if not, that's fine. I'll
There's a
it.
lot of words.
Okay, then I will go and have to get it. And I think everybody would probably like to see it then, because you don't want to jump too many. Is it undercurrent maybe? So this is a variable separable. Gotcha. Put it on view. It's towards the end, and I'll switch over to the screen. Okay, where the heck are we? Oh, we're down here. I lost the place. There it is. And kick in and share. So it's this guy here. You're right. That is a lot of words. So they make a reference to a thing called a previous exercise, and they formulated, in a previous, we formulated a model for this differential equation, which is, oh God, I know the name to this one. It's a population model. It's a logistic model, which is just the name for that population model, where PT measures the performance of some learning skill. Well, it's a population model, just means you learn through time. And K is a positive. Solve the differential equation. Okay. So we have dP by dt is some letter K, M take away P. And we're given a boundary condition that B of 0 equals 0. Let's do that part first. I think what makes this question less simple is that there aren't any numbers. K and M are fixed constants. I want you to think of them like plus C's. So K is 42 and M is 1,000,000, right? They don't change for the storyline. They're just not being given specific values because in different situations, K and M would be different because each human being has their own K and M. K would be a measure of IQ in one sense. You know, a measure of IQ is not how much you know. A measure of IQ is how easy it is for you to learn stuff. That's really a very rudimentary version of it. That's why there are some people with extremely high IQs and they are dumb. And the reason they are dumb is that they have no motivation. So they don't learn stuff, even though it's easy for them to learn. And people with smaller IQs can know a lot. And M is a measure of how much you know. So you can imagine this is a little model that represents what two people might have. So that's a number, that's a number. Since it is a variable separable, don't we need a fraction? And shouldn't T's be on the top, even though there aren't any here, it should still be in the top. And shouldn't P be in the bottom? And here is the first trick. Do you see that M minus P? Do you see I'm bringing it downstairs and calling it 1 over M minus P? I could have called it M minus P to the power of -1 if that helped, and then turn it into that. But that's what we've got. I can now do the old cross multiply. To try and give you an idea of what I'm doing here, let's put in numbers. This would be an example of that, right? Now, if I said to you, do this guy, I hope you might have said, well, I need a fraction and I need P to be on the bottom. So when it's on the top, you make it a negative power. Why am I rating this -1 power as a fraction, which is something I typically wouldn't do? Why am I not leaving it as a -1? Why am I rating it like this?
Because it's easier to deal with when you take the integral.
Right. When you integrate, don't you not want -1 as your power to use the power rule line? Isn't that special log situation? Right. Now, if you find the log, right, so this is what it would look like with numbers. If you find the integral of this guy, don't you get a natural log? So when you integrate this guy, you will get a natural log. Do you get anything else? Anything else?
Is it
What?
a negative natural log?
You get a negative. Agreed? And if you take a number, in this case 42, and you integrate it with respect to t, you get that. So if you take a number, you get that. Can you see my number version and my letter version are the same math? And I don't suggest it, but that's just me. But some people might want to do the question with numbers just to get a feel for the process and then go back and do the letters. If you had time, you could probably do that. Now, there is only one P here. It is very, very well hidden. Agreed? But there's only one P here. Doesn't that mean then I should be able to convert this into a P equals question? So let's go for it. What could I do to both sides to slowly get to that place where eventually I'm going to have P? What would be the first thing to take care of?
Divide by -1.
So I get this guy. And I'll keep WebAssign happy by calling that -c, even although that drives me crazy. You see the equivalence? Right. What do you do next?
Euler's number.
E to both sides. So E to this side gets you M minus P. E to this guy. So over here it would be 1 minus P is E to the -42 minus C. Remember, we're trying to get P on its own. So we're getting there, right? Very slowly, but we are getting there. What would I do to both sides next?
Subtract M.
Agreed. And what do I do now to get P, which is what we were after in the first place?
Multiply
Divide by
by -1.
If you multiply that by -1, which is exactly the thing you do, you get negative this and plus that. It just looks nicer if you write it that way around. Would you agree? M take away E is much nicer looking than minus E plus an M, right? Now, this is our general solution. I'm now going to use that guy, which says when T is 0, P is 0. And so I have this fella. And P is 0 when T is 0. That becomes E to the -c. Now remember, what we're after this time is we're after C. So it's a bit messy, but it should be doable. So what would you do to both sides to get closer to that C?
Subtract M.
Now if you subtract M, multiply both by -1. Yeah, we're getting there. What you going to do now?
Natural log.
So that makes C that fella. And I'm going to call it that fella because I think it looks nicer. Because negative log is m to the power of -1, and m to the power of -1 is this. That means we now have P, it's m, take away E. Oh, shooting space. I take that back. I like the answer, but I've taken it back. I'll tell you why in a second. It's that fella, take away C. And two negatives make a plus. And now I'm going to do something that's not very obvious. Is I'm going to take this e to the power of two things added and rewrite it as e to the first thing times e to the second. And the reason I want to do that is that isn't this m? And now I've got the style point version of the answer. The second part says what happens to this thing as t becomes infinite. Well, that becomes e to the negative infinity, which is essentially 0, because e to the negative infinity is the same thing as 1 over e to the infinity, which is 0. And so the whole thing just becomes m. And that would be the answer that you fit in.